In today's model, I'm going to be taking a simple barrier or wall, or you could pretend it's a dam if you'd like, and applying a simple hydrostatic load. So that's varying the pressure from a minimal at the highest point down to a maximum at the lowest point, which simulates the effects of having, a fluid inside a container or a fluid up against a wall. We'll start off by drawing our geometry. So I'm going to go into parts. It's a 3D deformable solid, and just going to draw a rectangle like that, and whatever depth it assigns is fine for this demonstration. The important thing to consider with hydrostatic loading is that the hydrostatic loading will vary in the z direction only. So you have to make sure that your model is orientated so that you want the lower pressure on top and the higher pressure on the bottom. So positive z is up this way and negative z is down here. So we've created the geometry, we just have to apply simple material properties. So whatever you'd like. Create the section and assign the section to the part. And then just assemble that instance. And okay, the boundary condition that I'm going to apply will be just a simple encastre, and it'll be on the bottom surface here. So just holding that in position. Now the bit that we have to do is apply the hydrostatic loading, bearing in mind that the z direction has to be upwards. So go into loads. Oh, sorry, I have to create a step first. Go into loads. It's a pressure. Okay, and we select this surface. And the distribution, change it from uniform to hydrostatic. The magnitude, you figure that out. That's just, the pressure equals rho mu h all multiplied by one another. So I'm just going to give it a random magnitude there. Okay, so the zero pressure height, so you have to figure out what the z coordinate is. In my model I'm going to pretend that the water goes up to the very top and right down to the very bottom here. So I'm just going to get the z coordinate for the top point. So tools, query, pointer node, and I'm going to select this. And I'm going to select the lowest point as well. So we can see here down in the bottom the z coordinate for the top point is 20 and the z coordinate for the bottom point is 0. Done. Okay, so we're back in here. So the zero pressure height is 20, so that's the height at which the water level is at. So theoretically the pressure is 0 there, and then the reference pressure height, that's just whatever height that particular magnitude is at. I've calculated the magnitude there as being the maximum pressure, so that would be at the very lowest point, so the reference pressure height is 0. I find that's the easiest way to do it, if you just keep the reference point as being the lowest point and just calculate the magnitude there. Now we just have to seed the model. And mesh. Create the job and run it. So if the job has finished running, we'll just go in and look at the results. And we can see, as expected, that the pressure increased going from the top down to the bottom there. There's 3 orders of magnitude difference. So that was just a quick example of how to carry out hydrostatic loading in Abaqus.